All right, welcome everyone. We're just going to wait 1 minute while people are filtered in from the waiting room, and we'll get started. Great. Well, let's go ahead and get started as people continue to filter in. Welcome everyone to the series and RMI webinar on the methane footprint of natural gas and coal. On your screen here in a second, you will see some disclaimer slides that we ask just that you read through as we go through just a couple of housekeeping items before we get into the substance of the webinar. So today's session is being recorded and shared after the event. We have closed captioning available for the webinar, which is accessible by clicking on the captioning button on your Zoom toolbar. You're welcome and in fact encouraged to submit questions in the Q&A box at the bottom of your screen as they occur to you. If there are points of clarification, we may get to them in a moment. Otherwise, we'll save them for the discussion, which we're hoping to save quite a bit of time for in the second half of the webinar. And we've already gotten a few questions, I think, from folks as they registered. So we've tried to integrate those into the structure of today's call. So I'm Andrew Logan. I direct the oil and gas program at Ceres. If those of you who don't know us, Ceres is a sustainability nonprofit that works with investors and companies to really transform the practices and policies that govern global capital markets in order to address the impacts of climate change and other sustainability threats. So we've worked for over 30 years with some of the biggest investors and companies in the world, both on their own sustainability plans, but also on state and federal policy and broader regulatory issues. So that's me and that's Ceres. You are here presumably because you understand or are curious about the importance of methane emissions to the world's ability to meet the goals of the Paris Climate Agreement. The International Energy Agency, the IEA, put out a report earlier this fall that made clear just how critical methane is. It essentially made the case that it's not possible for the world to get to a low carbon future if methane isn't addressed and addressed in an ambitious way. And one stat from that report that really stuck out to me was that making rapid cuts in the methane emissions from fossil fuels would have a greater emissions impact than taking all of the world's cars and trucks off the road immediately. So a good reminder that methane is a key issue. And as Debbie's report and her presentation make clear, it's an issue where details matter quite a bit. So, as you'll hear, there's a huge spread in methane intensity between different producers and basins. And there's a lot that producers can do to reduce their emissions. Essentially, at least from my point of view, being a heavy methane emitter is really a choice. And I hope we can all agree that that is a choice that we want to discourage when there are lots of tools available, many of them quite economic, to bring those emissions down. And so, both the report that Debbie and her team put out a few months ago, back in the summer, and the tool that she's going to be talking about today, really, equip investors with the detail and nuance that will help them engage companies to improve their performance. And that, at least from my, vantage point, is the real goal here. It's to underscore just how much room there is for improvement in addressing methane emissions in oil and gas, and reminding us why that is so critical. So with that long introduction, I do want to get to Debbie and get to the substance of the conversation. So I've known Debbie for many years, but one of the through lines in her work over that time, starting at the Carnegie Endowment and then now with Brown University and RMI, has been her really pioneering work to create public tools that help investors, companies, regulators, and other stakeholders better understand the climate footprint of different sources of oil and natural gas. And the work that you're going to be hearing about in a minute is really a continuation and extension of that work. So with that, Debbie, I'm going to pass to you for the actual presentation. We'll hear we'll hear from you. We'll see you demonstrate the new calculator, and then we'll move back to a discussion and Q&A. So Debbie, over to you.
Great. Thanks so much, Andrew. First, we were going to put up a poll because there has long been, and I would say for a generation, there's been an understanding out there, a conventional wisdom, I guess I would call it, out there about comparing gas to coal's climate impacts. So if you would kindly do this poll, we were curious to see what those that are attending with us today think about if they've heard about statistics of natural gas being half the emissions intensity of coal, and whether you believe this to be true. So just a minute to do that. And I don't know, Salika, if the results come up to you. Yep. So, 50-50. So almost split about coal and gas, or about gas being half as emissions intensive as coal, and a majority, well, a split between a majority of not thinking that's true and unsure. So this is great because we have a lot to discuss. Okay, so next slide. It is a misleading assumption that we've long, and I will say I definitely was in this camp as well. I agreed to understand that 25 years ago or so, as I was working on oil and gas and climate change, bringing in coal, that coal was the most emissions intensive, oil was in the middle, and then gas was 50% less than coal. What's not clear about that, and it's not that the calculation is wrong. What's wrong about this is it only accounts for end-use CO2. So in burning a million BTU of coal and a million BTU energy content of gas, there is a 50% difference. And gas is, in the end use, 50% less emissive in terms of CO2 only than coal. But it ignores several things. This ignores the fact that there's a life cycle emission to coal and gas. And interestingly, the life cycle of coal is the emissions are almost all in that end use. So on the coal side, yeah, it's mostly burning that ton of coal. But for gas, extracting, shipping, processing, maybe liquefying, shipping, regasifying, the whole gas life cycle has a much longer supply chain. And a lot of emissions are throughout that supply chain, not just in combusting gas at the end. This statistic also ignores the fact that methane, that greatly warms the planet, which I'll talk about in a second, comes from both gas and coal. But because the gas supply chain is so long, it leaks more throughout a whole supply chain versus just coal mine. And that also coal tends to have a lot of sulfur in it. And when sulfur is burned, it masks warming temporarily, which we'll talk about as well. So that's what this whole talk is about. When you add all of that together, the life cycle plus emissions beyond CO2, how do you compare? How much worse for the climate might gas be than coal, especially if it leaks? So next slide. As I think many of you probably are hearing, there's also been a long time of using 100-year global warming potential for all of these pollutants to compare the short-lived climate pollutants to CO2. And that really undercounts the emissions of pollutants like methane, which only have about a decade-long lifetime. And in that decade-long lifetime, the global warming potential that is an alternative brought up by the Intergovernmental Panel on Climate Change, the IPCC, is a 20-year global warming potential. Again, gas is gone after methane reacts in the atmosphere after 10 years. But if we bring this comparison from CO2 to methane to this 20-year global warming potential, 20-year time frame, the global warming potential puts methane at over 80 times more warming than CO2. So that matters. And that's the statistic that Andrew was saying at the beginning of what IEA is talking about now. We must deal with methane, and methane matters especially now. And methane has all of this warming compared to CO2, that to reduce methane now has a lot of benefit to the climate now. So the next slide. From the IPCC, This is in the most recent assessment report 6. The idea here is that there are all of these emissions, greenhouse gases, that come when you burn fossil fuels, and carbon dioxide, as you can see in the first bar, has led to a majority of warming, but methane is right up there next to it in terms of bringing a tremendous amount of warming into the atmosphere that we are experiencing now. And the other pollutant I wanted to draw out here, because it's in the calculator, is sulfur dioxide. So when you burn all the sulfur, much of it is in coal. Most of the coal around the world is pretty high sulfur, but there can be sulfur in gas as well. And when you burn any of this sulfur, turning it into sulfur dioxide, it actually, if you see the blue bar going down, it masks warming. It serves to actually reflect sunlight back out in a protective way, only for short term. The problem with sulfur dioxide in the lower atmosphere, though, is it's terrible for your lungs. So you don't want to burn sulfur and coal. This is a really bad thing, which is why we scrub coal. But to the extent that there's some unscrubbed coal around the world that goes, and the sulfur dioxide goes into the atmosphere, this will mask warming in the short term. So this all goes to the point that you don't want to replace, and this is the takeaway from this entire presentation. You don't want to replace gas into a system when it leaks, because if you take away coal, which we need to do for global warming, but if you take away coal and replace it with leaky gas, which has a lot of methane in it, right away you're going to make the atmosphere feel the pain. We're going to have a lot more heat in our atmosphere. So next slide. Methane, we're starting to see this with satellites that are going up. Carbon Mapper is putting up its first 2 satellites, and EDF is putting up Methane Sat. These are publicly, nonprofit public satellites. There are also government satellites up that can measure methane. And these images are from flyovers with the equipment that will be in the satellites. We're seeing super emitter events, especially from the natural gas supply chain, but also in oil and also in coal and also in landfills. You see this in different sectors beyond oil and gas. But these leaks happen far more often than we've understood historically, because methane is invisible to the naked eye. These are enhanced images. It is odorless when it comes out of the ground, and it is pressurized. So it comes out in volumes when it leaks. And this all goes to the fact that we need to get far better at monitoring and measuring and stopping methane leakage. This is an active problem that the industry has today that it's aware of, but until now, it hasn't been a priority to stop. And going into COP28, this is a major priority for this industry, especially with a COP in UAE, where oil and gas is such an issue. And the next slide. We've modeled, RMI has a tool called the Oil Climate Index Plus Gas. It's been around for 10 years. I started it, as Andrew said, when I was at the Carnegie Endowment, and it assesses the emissions, it quantifies the emissions from otherwise equivalent barrels of oil and gas. And so it puts it on a, barrel of oil equivalent basis. And this is the output from modeling about 2/3 of the world's oil and gas assets. So, every oil and gas field for about 2/3 of them in the world, we're now increasing this modeling to about 75% of all oil and gas produced in the world. But the takeaway from this message is that a majority, over half of the emissions that come from oil and gas today are from methane. So you can imagine this bar, if we were to take away the blue and just erase it and just drive down all of these bars, the whole entire graph of emissions from oil and gas would go down very quickly. In other words, not leaking methane from the oil and gas supply chain, and from the oil supply chain, it's with associated gas. So not leaking gas in these systems really matters to the climate. And it will help with this 1.5 degree alignment that Andrew talked about. Next slide. So just before we get into the calculator, which I'll share, I just wanted to talk a little bit, and this will come up. Feel free to bring up any of this, ask more questions in Q&A. But what's so interesting here is it's not it's for a lack of trying, I will say, that methane is a problem today in the oil and gas space. It's not been a priority. Early on, it was not recognized as a precursor to ozone, so it was not seen as a climate pollutant. About 30 years ago, methane was discounted as a concern. Climate change wasn't yet raised as a major concern. And when climate was raised as a concern in the late 80s, it became all about the focus on CO2. And had we done our work correctly with CO2 and really mitigated CO2 a generation ago, we might not be talking so strenuously about methane, but we didn't attend enough to CO2, which is why the planet is heating up so much. And now the super pollutants like methane matter more than ever. But the good news here is that there are solutions at the ready. So we need to fund these satellites. We need to make data publicly available. We need to integrate point source super emitters into models so that we know how to point those satellites to then further identify super emitters so we know where to look and what to fix when. We need to prevent equipment leakage in operations. This includes maintenance fixes. There's a lot of things that you can do at the field. Eliminating flaring and venting from operations, just putting your methane into the atmosphere as a routine operation has to be stopped. We need to set performance standards and certify that oil and gas systems are low methane leakage, which definitely is being done right now. There's a lot of talk about reducing or certifying emissions below 0.2% leakage, which I'll talk about in the calculator in a second. And lastly, in terms of transparency, there is not enough transparency in the system. Industry self-reported emissions are often way higher than what is realistic. So we need to increase that transparency to publicly provide methane data. And we need to charge these fees under the Inflation Reduction Act, these methane waste fees, that are accurate and fair to the industry so that we really let competition work in order to reduce emissions. So there's a lot to be done financially, operationally, with regulation. There's just so much opportunity here to stop this problem. And next slide. So now I want to bring up the calculator and show you. So we've created a calculator out of the, doing this environmental research letters study that Andrew mentioned that you can read, and it's an academic study, but it led us to really try to understand all these variables because you have life cycle emissions of different amounts depending on what type of gas and where it's going. You've got different types of leakage of methane from both gas and coal. And you have different warming potentials you can turn on and off, 20-year, 100-year. There are a lot of variables here. And the more specific you get, the more you know whether making a substitution of gas for coal is a really bad thing for the environment, for the climate, or not. So we ran these, basically, this is a user-defined here. I'll go back here, and you could see this is a user-defined. In the study, we put in user-defined values, and I'll walk through those in a second. Up at the top, it shows you the life cycle greenhouse gas emissions from gas versus the life cycle greenhouse gas emissions from coal, and which one is higher. In this case, it's basically parity, but coal is slightly higher in this first run. And it comes out to about 0.3, 0.2%. You want to be below those numbers to not make the climate worse if you ever were to substitute gas for coal. And then we ran a couple of scenarios, which I'll go through in a sec, but you could see how substituting West Virginia gas for West Virginia coal with the inputs from West Virginia that are publicly available, the parity is about 1.3%. So if your gas leaks in West Virginia more than 1.3%, you're as bad as coal. You don't want to do that. You really want to tap out and stop gas from leaking, around the 1% mark. Whereas another scenario we ran, which shows that if you're going to take Permian gas from Texas and you're going to liquefy it and ship it to China and replace it for coal in the only China, then you want to be in the 0.2% range, because with that whole life cycle of the gas and all the leakage that can go on there, if you replace that coal with any gas that's above, say, 0.29, 0.3%, you're going to not have a better situation for the atmosphere than terribly that coal burning, coming out of the ground and being burned in China. So you really want to replace the coal with renewables in that case, rather than with leaky gas from Permian, because you're not going to benefit the climate if you take that leaking gas from Permian. So going back here, I just want to show you quickly the variables that we have here and let you know that this calculator has both toggles that you can play with, or we can, if you're at all interested, we can send you the model for your own discrete inputs, because we've selected a couple of sliders and inputs for ease of use, but you can definitely use your own. So there's the global warming potential that you can either toggle to 20-year, 100-year. We default to 20-year again, because methane has a very short life, and using a 100-year global warming potential totally minimizes the emissions. The SO2 emissions can be with or without aerosol reactions. SO2 reacts with clouds, and it masks climate even more when you assume that there's any sort of aerosol cloud interaction. So we default conservatively without aerosol interactions. You can look at the emissions from methane here from gas side. You can put in your own leakage rate. You can change the content of the methane in the gas, which varies from about 70 to 90%. It really is variable. You can put in different contents of sulfur in gas and how efficient the acid treatment removal of that sulfur is for acid gas removal. When you keep, I will say, sulfur in the gas stream, you can't put it in a pipeline. You have to remove it at the source because it's very corrosive to pipelines. Unlike the coal, the sulfur in coal, it just goes with the coal to the power plant and then is scrubbed, often not very well. In the gas side, you have to remove it upstream. And then you can talk about different low life cycle of gas, mid life cycle of gas. The high is more of an LNG supply chain. And then similarly, just a few more inputs here on the coal side, we have different coal mine methane assumptions. The one is the IPCC factor. This is outburst coal mines that are found all over the world, especially in China. The satellites are going to really pick up coal mine methane too, so we'll be able to improve these over time. Low coal mine methane, no coal mine methane. Again, sulfur dioxide, you have what's the content of the sulfur in the coal, some discrete choices. What's your scrubber efficiency? We found in China, the average scrubber efficiency is about 50%, usually on off, which is really a problem for putting a lot of sulfur in the atmosphere, but it masks warming right now. And then again, the coal life cycle emissions. Are you a low sulfur, low coal, low CO2 coal supply chain mid, or do you have high CO2 emissions in your coal? So those are all the inputs. You can download raw calculations. You can ask us for the actual calculator. You can play with this calculator, but everything you pick and choose that I went through below will change this parity line between coal and gas to give you a sense of whether you should often skip over replacing anything in coal with gas because it is so dangerous for the climate, the methane content, and go right to renewables, which is often the better substitution for coal, especially in power. So, Andrew, back over to you. Oh, I'll stop sharing.
Great, thank you, Debbie. That was amazing and a bit sobering. Just when I think about, the parity points that you highlight with the tool and what we know about the actual emissions from some of these basins, right? I think for the Permian, you for that particular kind of coal, I think you had 1.3%. The leakage rate needs to be below. No, sorry, it was like 0.2 something percent actually. It was quite a low leakage rate, and yet we know that in the Permian, leakage rates are somewhere. I mean, it varies depending on where you look and how you look, but 3, 5, 6%, maybe 9%, depending on whom you believe and when you look. So, I guess one just initial question is just given that very large gap, how much should we or should investors focus on narrowing that gap versus, as you say, kind of making the leap to some other kind of source for energy?
Yeah, no, I think it has to be, we're at a point in the climate, in the warming of the atmosphere, where we have to do everything. No, and it puts us in a really difficult situation. It's much easier when you are very focused, you could solve a problem with a very structured, taking steps. I think we need far more transparency, and the satellites will provide that. But with the satellites, nothing is free. And public information, you think of even like public radio, you have to fund things. And so the satellites, I think, to really grow them and have dedicated satellite detection, we need funding for satellites. And I put investors squarely in that space. But also, I think that the operators and the reduction of those emissions and operating very differently and prioritizing methane management is the name of the game right now. And that will definitely be a conversation at COP. So I'd say there's something for everyone to do here. And I don't want to X out. It's not just at the field level, at the point of production. A very big point of methane leakage also happens in pipelines. So it's really the whole, and then when you put LNG, the liquefied natural gas part, in shipping and regasification, you're really talking about management through the whole supply chain.
Great, thank you. And we're already getting questions in the Q&A, so please continue to add questions to there, and we'll try to address all of them hopefully in the next 25 minutes or so. And I've got some questions I want to explore as well, just because I think this is such a fascinating tool, and you only had a short amount of time to highlight it. So I want to, I guess, dig into some of the implications. I think one of the takeaways from your work, this work, but just also your historic work on both oil and natural gas, is just how much variability there is in the emissions profiles of different sources of oil and gas. I'd love to kind of hear your thoughts on how changeable are those emissions profiles for particular sources. I think of somewhere like the San Juan Basin, right, in New Mexico, and that's just an old basin with old wells and old infrastructure and old equipment. And it's sort of hard to imagine the operators there spending the money to sort of plug those leaks and fix that equipment. So I guess how much of this, if you're an investor looking at this data, how much is this a call to engage with companies to lower their emissions, and how much of it is it a tool to sort of identify companies to invest in and maybe companies or basins to avoid?
Yeah, I mean, the real takeaway from this oil climate index plus gas, you said it, Andrew, it's really about how varying. It's not one number. I mean, there's a factor of over 10x in terms of emissions per equivalent barrel of oil or gas between different parts of the world, different resources, different management practices, different energy sources to lift and extract and process, leakage rates. So the details matter a lot. And I think you have to combine them. So if you're serious, we're serious about, reducing our dependence on oil and gas, which is what the IPCC and IEA have been all about in terms of dealing with climate, fossil fuel consumption. Because remember, there's also end use when we burn all this stuff, and there's a lot of CO2 there. So we need to start to dial this down. But then the question is, which assets do we dial down first? And if we pick the right assets with the largest intensity, we're going to have a lot more benefit right away to the climate than picking off those assets that have a much lower climate intensity. And there's also a tremendous motivation here. And I think your question zeroes in on this a bit, because there are legacy producers out there all over the world. We've been operating the Permian for like 135 years. So, Spindletop was 1902. So this has been happening a long time. And there is an opportunity to stay in the game if you really want to manage your emissions and bring that into, your whole operational intelligence. But there's also an opportunity here to ask what oil and gas deserve to remain in the economy. And in the global south, we're working on this, but in the global south with new producers, and we don't want to turn on new sources, but we know we want to turn off intensive sources, to couple the energy poverty in country with domestic renewables and then run your oil and gas only on renewable electricity. Because right now, oil and gas runs on diesel and natural gas. You put a lot of diesel and natural gas into extraction and processing and shipping. And so coupling this together could really solve two things: bring down the intensity of what gas remains in the market, and then also remove energy poverty on the backs of renewables for those in the global south that really need energy. So thinking broadly about this, I think, helps us understand that there are lots of different directions to go, many of which start to reduce the footprint of oil and gas.
Great. So I'm gonna dip into some of the audience questions, some of which are sort of detailed and specific, and then we'll come back to some higher level discussion items. So one person is just asking about whether there is sort of a guidance document for the tool. So, how do users sort of understand the implications of all the assumptions that you're highlighting? So I'll throw that, and then I'll throw one more to you just to let you answer them both. Sort of a question about LNG and assumptions around LNG, because a lot depends on the ship and where it's going, and the company and steps they're taking. So if you could talk through both, more broadly, how do investors think about using the tool, and then kind of how you thought about LNG when you kind of built this out.
Sure. So the best guidance document for this is the article, the Environmental Research Letters article that we wrote that published in July. And we had great co-authors, Harvard and Duke, and also from NASA Jet Propulsion Lab. So fantastic co-authors on this. And there's a supplemental information, and each input in the calculator is detailed in that article. So maybe Shannon, you could put that in the link here so everyone can see, you can have that journal article, but you can also look up my name, ERL. You could search on Google for it too. LNG is really interesting. So like everything in this industry, right, even from the final footprint, but everything that leads up to that, the activity data is just not nearly as transparent enough, and there's a lot of variability. And that's why the calculator was created, to get that information so you can actually do these very site-specific, which ship, which port, did it leak? How far did it go? Who regasified it? There's even the case that in China, sometimes depending on how gas moves, it might be put on a truck and sent around. It doesn't even go into a pipeline. So there's a lot of variance in the world on this. And that just calls to the fore a lot more transparency. When I showed you that example, I took that LNG supply chain emissions from an article that Dave Allen from the University of Texas did. He did a fantastic article comparing Permian gas via LNG to China. And so I took a lot of input details there, but it was one case study. So to underscore the fact that generalities in the oil and gas and coal space just don't work. You really need specifics, which underscores why transparency is the top priority here.
Great. So there's another question that asks about, kind of broadly about methane fees, and maybe I'll broaden that out a bit because I'm really curious. It feels like we're at this really interesting moment in methane, right, where we're on the cusp of both finally having regulation, at least in the U.S., to address methane, both the Inflation Reduction Act, methane fee, and then hopefully fairly soon the EPA's methane rules. So those will take a few years to come into effect. So we're going to be pricing methane, at least in some cases. And we're also, sort of feels like on the verge of, or in the middle of, this real revolution in technology around detection and measurement. And so, I guess I'd sort of be curious if you think ahead, a few years, like how is this conversation going to change, hopefully, and what can the sort of people who are on this call, whether it's investors or banks or companies, sort of help make sure that we sort of use this moment to the utmost.
Yeah, so the Inflation Reduction Act set this waste methane fee it will start at $900 per ton of methane. And then I think in 2026 it moves up to $1,500 per ton. This is historic. I really want to underscore this. I mean, a lot about IRA. The Inflation Reduction Act was historic, but the methane fee, to my mind, was the single most historic thing. We have been trying for a generation to price carbon, and we have not successfully priced carbon, especially in the US. We just, and if you don't price something, it just doesn't matter in decision making. That's, we live and die on the sword of, dollars. And so it does matter a lot. One of the issues that I think, looking ahead on this, Andrew, one of the issues is that this industry is hyper competitive. It used to be on the gas side, gas was pretty regional, but with LNG, gas has gone global, and we know oil markets are totally globally competitive. I mean, anything could happen anywhere in the world, and it will change the price halfway around the world. Very competitive. This does several things. So self-reported emissions don't work. We know this with the greenhouse gas reporting program that EPA has, so we can't charge the methane fees solely on self-reported emissions. What's great about the methane fee is putting a price to self-reported emissions means that they'll only improve, because if I'm operator one and I see operator two not reporting accurately, I want to say something because it's so competitive. I don't want them to pay less than they should. And so I think that this Inflation Reduction Act methane fee will really improve. It will use satellite data. It will improve certification. It will bring a lot more confidence and verification into this whole system, which again, will only make this whole system reduce its emissions because it will be verifiably, seen. And the industry is going to help each other do that, I think, by, pointing fingers, and the financial institutions and banks can accelerate that.
What are your, I guess, your, on the technology side, I feel like one here is very different levels of optimism, I guess, about the state of technology, particularly, the ability of different technologies to sort of attribute emissions to a particular company, right? Particularly, somewhere like the Permian, where there's a lot of wells and infrastructure in a pretty tight space. And I wonder just, how should investors think about the idea that, on the one hand, I think we know that we need to move as an industry toward more direct measurement, with this idea that it might take a few years to really get the ability to accurately sort of inventory emissions by company, that yet you don't want that to be an excuse, obviously, to go slowly. So it feels like, the science is advancing quickly, but maybe not as quickly as, the world needs. And so, how do you talk to companies about that? Because I think, we hear different responses from companies, some saying, look, we have to just wait for the technology to catch up, and others, taking maybe a more ambitious approach.
So this is a very variable state of affairs. I started my career, I don't know if you even know this, Andrew, I started my career at Chevron. So, in the field, in Bakersfield, with soap bubbles, looking for leaks many moons ago. It's a highly variable, there's a lot of intermittency, there's a lot of things that go on. So I guess I'm saying this to have folks appreciate that this is a never-ending quest. There's no reason to go slow right now. There's every reason to go fast. We need a lot of detection. 1, 2, 3, 4 satellites won't do it. The more satellites, we need a system of systems, which will include a whole array of satellites. The more you have, the more you can do very specific things with satellites. You could train a satellite just on the Permian, for the rest of its time in space. You wouldn't want to do that if there's only 3 satellites in space, but that's a really important basin, and you want to know what's leaking where, and you could put a point source emission satellite there that would know, and it would just push broom the Permian. But we need more satellites to be able to do that. We need inline sensors. When is the flare pilot out and it's just pumping methane into the atmosphere? So that would be inline sensors. There needs to be more detection. I'm trying to think, it's almost like an analogy maybe that will make sense for financials, is like, I really appreciate the fact that my bank calls me if there's like a big amount of money that's just left my account. They are monitoring me, both my credit cards, my bank, they're monitoring me all the time to make sure that there's not fraud. This is that type of a situation for methane in the atmosphere. And to make matters better, that methane that doesn't leak is worth hundreds of billions of dollars to the industry to sell, and to climate damage that we didn't pay for that would have happened when it did leak. So there's a lot of reward on the other side, just like there is a lot of reward to banks that there's not fraud in my accounts that they're going to have to help me cover. So I think that there's, a real desire to have more information, just the way the banks do now on everything that we do in the economy.
Great. So there's a question now which is asking about drones, and maybe this is a good sort of cue to kind of again broaden out things a bit. And I don't know kind of how closely you follow all these different technologies. There's lasers. I'm excited by lasers, drones, helicopters, trucks, planes, satellites. I mean, are you in a position to sort of give a quick tour of the state of the art? Because it's super interesting to me, at least, how complicated it is in an interesting way to sort of try to track these emissions, but also just how a lot of the approaches, they all have trade-offs and pluses and minuses, right? You sort of can't just say a satellite's going to solve all of our problems. The satellite solves some of our problems and then creates others. So we'd love to hear you kind of expand on that.
Yeah, and to step back, all satellites are different. They do very different things. So you need a system of satellites because some of them are point source, some are area source, some have granularities, some actually look at the flux in the atmosphere. There are all different types of satellites. So each of these pieces of equipment, each of this instrumentation does different things well. I think, and you can go think about it from going from the sky in orbit, and that would be all the satellites, and then you go to aircraft that are, flying over a certain area. But the benefit of a satellite over an aircraft is you don't need permission. Once you fly aircraft over Iran to see if they're leaking, you need permission. So the satellites have a tremendous benefit of being able to see, just depending on what they're designed to see. You mean a lot of them to see everything, but they can see things that when you get lower to the ground, you need more and more permission and more connection to the operation, all the way down to a drone that you would fly, there, and then going down to inline instrumentation, and then also cars that have detection equipment on them that can go drive around the perimeter, especially if you're, say, a gas plant in Louisiana near a neighborhood, you might want to have something that's literally going around the streets to detect. So lots of different opportunities there. But the big underpinning of them working is the allowance of third-party reporting. So once we have all of these different series of detection, you need to put it somewhere. Like if you're going to see a leak, you need to know who to call. And so we need systems that actually allow that type of reporting and verification to go into the regulation and the pricing and the charging on emissions. Because having all this information, if you have no place to put it, we did this with cars where we had I know I lived in California for many years. I don't know if other states did it, but smog reporting. And if you saw a truck or a car belching smoke, or you would go past a perimeter where your car was detected remotely as being a super emitter, then you could call that in to the California Air Resources Board. So we need that type of, and that will go in internationally. IMEO, the Methane Observatory, will take that type of emission, and EPA should take that type of emission. We'll see what the regulations do. So depending on where you are in the world, we need a place to put all of that detection.
Yeah, and that was at least in the draft EPA rules, that was part of what they're proposing, right? Is allowing third parties. You have to go through a bit of a certification process. It can't just be a person with a camera, but it is set up in a way, or at least it may be set up in a way that allows citizen groups to detect, leaks, and then does, impose an obligation on companies to actually address them. So that, assuming that makes it to the final rule and is done in a way that isn't super burdensome, that's exciting. But as you say, it's a long way from individual people finding leaks to something that rolls that up into a more useful set of data. Is another question in the chat about, I mean, they ask about ethanol, but again, I guess I would say maybe broaden this just to talk about natural gas utilization. I mean, there's lots of things that companies are doing, whether it's mobile Bitcoin mines to turning isolated gas into to methanol or ethanol or NGLs. Is there anything in the tool? I mean, that's a pretty granular use case, I guess. But I guess how do you think about that aspect of natural gas end use?
Yeah. So it's interesting. A lot of processing obviously goes into making stuff. You know, ethanol I wouldn't put as stuff. It's an actual, if you're going to burn it as a fuel, it actually has an end use emission. But a lot of gas goes into my sweater made of rayon, into medicine, into plastic, obviously, plastic bottles, goes into, pretty much life as we know it has a lot of gas embedded in it. And some of that isn't burned in its end use. It's actually, locked in. Like you're not going to get any sort of emissions out of my sweater, maybe if it goes into an incinerator someday. Um, so again, these life cycle emissions are very variable, depending on both what you do to manufacture something and then what the end use product is to do it. And that's what the Oil Climate Index plus gas is working on. So we have the whole life cycle charted out. Right now we're doing more and more in plastics, but ideally to know where your feedstock goes becomes an important part of the life cycle. And ethanol, what do I think about ethanol? I mean, if the goal is really to not use hydrocarbons, then ethanol is a hydrocarbon. We have to be really careful about not perpetuating the industry. At the same time, there are going to be some hydrocarbons like making medicine or, everything plastic, all of the medical equipment that we used in COVID, it's all made of hydrocarbon. Some things are jet fuel, some things going to be hard. They're not going to be the easy stuff. You can't, like an electric vehicle might be on the easier end, and roadways, paving roads is on a harder end because it's made all out of hydrocarbon and we're not replacing it tomorrow. So we need to be mindful of, again, those life cycle substitutes and it goes back to the calculator, just making sure with the substitutes shouldn't be as bad or worse than what's happening today.
Makes sense. Here's a pretty interesting question. So the person asks if there's any significant input that is missing in the calculator, or maybe I would add, something you would want to add in the future, but couldn't for whatever reason now.
Yeah, the only other thing I think, and I've been thinking a lot about this, but it's the next climate pollutant that we'll pay attention to. It's funny how the problem continues to become difficult, the climate problem. So we keep on drilling down on different ways to deal with it. And so we've gone from CO2 focus now to a methane focus. And I think another big focus of this is black carbon. And black carbon has an organic part that cools. It was in the slide that you can look back at later, and an inorganic part that warms. So black carbon is complicated, and but coal puts out a lot of black carbon when you burn it. So the idea of understanding better black carbon is something that I would love to see in the calculator. Ultimately, the thing is that it might even itself out, depending on what type of carbon is actually hitting the atmosphere when you burn coal.
So I guess to ask maybe a provocative question, have you heard from any coal companies since this tool has been released? I mean, one could imagine a cynical coal company sort of trying to make use of this in a way that, said, hey, look, we're not, we're cheaper and maybe we're not as bad for the climate as natural gas as it is currently produced.
No, it's a good question. No coal companies reached out, and the way that we've really thought about this was not in any way to excuse coal, because it is by far, especially in terms of public health, which is also discussed in the paper, in the journal article, but coal is devastating. Its time has come because there are already substitutes for it, especially renewables. And the idea of coal justifying itself, I think, is not where they're at right now. I was interested to do the West Virginia case because it is a state within its own borders that jockeys between coal and gas. And so seeing that 1.4% cutoff, at least from the data I could find on what West Virginia's coal and West Virginia's gas, what its characteristics are, I thought was interesting. And I don't know, the satellites will help us understand better Marcellus gas to understand just how leaky that gas is. But I wasn't expecting coal companies to justify themselves on this because it's time. coal is, and CO2. I often liken it to like the bathtub is full. CO2 is like the bathtub is full, and methane is the spigot that keeps on running into this. And so the methane is running over the edge really quickly. I don't think that any high carbon fuel like coal has a place right now given where the atmosphere is at.
Well, I guess we'll take that as a sign of progress that nobody has leapt to that opportunity. We have time for just maybe 2 or 3 more questions, so feel free to add any to the chat. There's one
You have a question?
here, but sorry,
Can I ask you a question?
you may.
Yeah. So I wanted to ask you, what questions could banks and financial institutions be asking of the companies that they do business with?
Well, that is a great question. So I would say, I would say a couple of things. One is that EDF has a great guide for investors that I would kind of encourage everyone to look to. It's very detailed in terms of the kinds of questions they would recommend that that investors ask companies about their approach to methane mitigation. I would say just at a higher level, though. I mean, to me, and I think your work really makes this clear. I mean, one of the key things to understand is really just how are companies thinking about measuring their emissions in the first place, right? I think one of the interesting implications of what we're learning about methane emissions is that not only have we been underestimating them, but I think the current approach or the historic approach relying on estimates has focused companies' attention sometimes in the wrong places, right? So, missing whole categories of leaks that it turned out to be incredibly important. So I think it's a really foundational issue for companies, whether they are sort of happy with the status quo or they are moving through whatever process toward a new approach that is much more based on direct measurement and mitigation. So that's kind of where I would start. I will, yeah, we're getting a lot of questions in the chat though, so I will maybe pivot us to those. Can you see those, Debbie, or should I kind of read them out? There's one, there's two that really relate to kind of different kinds of coal mines in a basin, and whether you differentiate between sort of new mines versus older ones, which might have different kind of emissions profiles. So people digging into the details here in a good way.
Yeah, I think we're going to learn a lot about coal mine methane from satellites. One thing that's been, I really think they've been understudied. I don't think we have a concept of how big the pie is on coal mine methane. One of the big issues about coal mines is they're more of what I would call an area source, because the coal seam can go for quite a ways, and you'll have a mine and a shaft, but you'll have a whole area. And I am not a coal expert by any means. That was a big growing part. I know oil and gas. I'm not the coal expert to ask, but I think that the satellites are going to see a lot more emissions right now. Globally, I think it's about 9% of man-made methane emissions are thought to come from coal mines. I have no idea if that is going to be reconsidered. So the idea between new and old coal mines, coal mine methane, which is a form of getting gas out of coal mines, and just sheerly both open pit and also underground mines, there's a lot of variance in coal and in the coal practice that I think we're going to learn from satellites.
Great. And maybe we'll end on sort of a positive, not that this hasn't been overall positive, but just kind of looking ahead, right? Kind of how do we catalyze greater ambition in this sector? I mean, I think you've highlighted the need for more kind of publicly accessible, transparent data, and some of the technologies, certainly satellites and arguably overflights as well. I mean, they're expensive, but they really benefit the industry as a whole, or they could, right? Because they could provide data for everyone. So I guess, what are your thoughts on, how do we finance that, right? I mean, there's public finance, that's one option, but just to my mind, there is a real financial incentive here for banks, for companies to want to get together in some fashion and and generate, create these resources that provide data to anyone who wants it, both for operators, right, who can use it to address leaks, but also for the public to understand kind of where the emissions are coming from. So I guess this is the leading question, I suppose, but just kind of curious for your thoughts on that. But yeah, maybe more specifically, like, how would you carry that conversation forward?
Yeah, I mean, money on the table will surely help. It turns out that depending on the price of gas in the market, and the International Energy Agency has done these marginal cost abatement curves that, if anyone's interested, follow up. We can share that with you. But it turns out that anywhere between half and 80% of the emissions from methane from oil and gas are actually, you can reduce them either at no net cost, either very low no net cost, or a profit. So the idea of incentivizing that, a little bit can go a really long way. When something is profitable, it still has a payback. There's still impediments. Markets are sticky. Operations are difficult to change. Mindsets are hard. Companies vary. So incentivizing a little bit can go a tremendously long way here in terms of changing out operations and electrifying systems, putting in place different, detection, monitoring, reporting, verification systems, truing up self-reported emissions. A little bit can go a long way. And I think that the financial community is in a great position to nudge and move this along, and to make satellite and remote sense data open source. Because it's harder for the operators to say, hey, show everything of the world of what I'm doing to everyone. It's much easier for their financial arms that are trying to do net zero banking and have other different avenues to reduce emissions to say, and we're going to make this infinitely transparent.
Well, we didn't plan that, but that was a great note on, I think, on which to begin to wrap up. So as a reminder to everyone, this webinar was recorded. We'll make the recording available. We'll make the slide deck available. We'll also send a follow-up email that includes links to the tool and I think some reports that RMI has put out. So kind of a good place to start as you think about where to take this information going forward. So I just want to thank Debbie again and RMI for this incredibly useful tool, but also for spending the time with all of us today. I mean, as you heard, hopefully, high methane emissions are not inevitable. They are essentially a choice of prioritization of where to spend time and money. So I would hope that investors really take away from this conversation that there are tools to engage with companies around their emissions, both how they're measuring them and how they're prioritizing addressing those emissions. So thanks to everyone. Just a couple of, I guess, quick housekeeping items to run through before we let everyone go. I just wanted to highlight for everyone, one of the series areas for focus right now is protecting the freedom to invest. So I would encourage folks to visit our website to learn more about that. In addition, on the next slide, you can visit our website to access all of our reports, including an annual benchmarking exercise we've done on industry methane emissions. And finally, we were to ask that folks follow us at COP28. And then finally, we've got a survey for folks to fill out to tell us how we did and how we can improve in the future. So thanks again, everyone, especially Debbie and her team, and look forward to working with you on this going forward.